Hello everyone, and welcome back to my channel. This is Vishnu Manjupudi, and I'm glad that you are all here. Today, we will be solving the 2019 AMC 8, problems number 1 through 5. So, without further ado, let's get started. So, let's begin with problem number 1. We have that Ike and Mike go into a sandwich shop with a total of $30 to spend. That's important. Sandwiches cost $4.50 each. That's also important. And soft drinks cost $1 each. That's also important. So Ike and Mike plan to buy as many sandwiches as they can and use any remaining money to buy soft drinks. Counting both soft drinks and sandwiches, how many items will they buy? So we know that they buy as many sandwiches and use remaining money to buy soft drinks. So all we have to do is find the maximum number of sandwiches that Ike and Mike can buy. We know that there are $4.5 per each sandwich, and they have $30 in total. So we can just divide. So we have $30.00 divided by $4.50, because that's how much a sandwich costs, equals, well, what do we have? Well, $4.50 goes into 30 6 times, because 6 times $4.50 is $27. So we have 6. And then what do we have left? Well, we have $30 minus $27 equals $3. So we have 6 plus $3 over the $4.5. Now, if we notice that they can only buy an integer number of sandwiches, we have that they buy 6 sandwiches in total with $3 left over. So now, what do they do with these $3? Well, they use any remaining money to buy soft drinks. So they have $3. Okay, so they have $3. And it costs $1 per soft drink. So again, we just divide. This gives us 3 soft drinks. So, in total, we have 6 sandwiches plus 3 soft drinks. That's okay, which equals a total of 9 items. And we have 9. And when we look back at our answer choices, we see 9 is choice D, and we are done with this problem. Now, let's move on to problem number 2. 3 identical rectangles are put together to form rectangle ABCD. So we know that 3 identical rectangles, that's important. And now, this is the rectangle ABCD. Given that the length of the shorter side, so length of shorter side is of each of the smaller rectangles is 5 feet, what is the area in square feet of ABCD? Well, this problem might seem pretty hard at first, until you realize that this is a rectangle, which means that these two lengths must be the same. So we have AD is equal to BC, and we also have width and width. So you have AB equals CD. So because of that, we already know that the shorter side is 5. So we also know that this is the shorter side, right? So this is 5, this is 5, and this is 5. Okay? So now we have 3 sides that we know. Now we use the fact that AD is equal to BC to find L. AD is equal to 5 plus 5, which is equal to 10. Therefore, since BC is equal to AD, BC is also equal to 10. So now we have the length of the rectangle. Now what about the width? Well, here we have that the length of BC is also the length of the short rectangle, right? This is the length of the short rectangle, the width of the large rectangle. So, because of this, we know that this length is also equal to BC, or 10. Thus, we know that AB is equal to 10 from this segment right here, plus 5 from this portion right here, which is equal to 15. And finally, we find out the area. The area is just equal to AB times, we have AD, which is equal to 15 times 10, or 150. And looking back at the answer choices, we see that 150 is answer choice E, and we are done. Next, let's move on to problem number 3. Which of the following is the correct order of the fractions 15 over 11, 19 over 15, and 17 over 13 from least to greatest? Now, how should we approach this? Well, it seems like we could cross multiply in order to find the fractions that are the smallest, but this seems very tedious. So what I'm going to start by doing is subtracting 1 from each of the fractions, and that should preserve the inequality because I'm subtracting the same value. So when we subtract 1, we have that the correct order is the same as 15 over 11 minus 1, which is 4 over 11, 19 over 15 minus 1, which is 4 divided by 15, and 17 over 13 minus 1, which is 4 divided by 13. And now, these fractions are really easy to compare because they all have the same numerator, and thus, the fractions with the lowest denominators are the greatest. So in this case, 4 over 11 is the greatest, then we have 4 over 13 is second, and 4 over 15 is last, which means that since the order is preserved in our initial one, 15 over 11 is the greatest, 7 over 13 is the middle one, and 19 over 15 is the smallest. So the smallest one should be the leftmost value because it's from least to greatest. So we see that only D and E have the leftmost value of 19 over 5. So we can just cross out A, B, and C. Now we look at the middle value. Here we can see that the middle value is 17 over 13. And out of them, E is the one which has the middle value, 7 over 13, and we are done with this problem. Alright, problem number 4. Quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of diagonal AC is 24 meters. What is the area in square meters of ABCD? So, a key fact about rhombuses that you need to know for this problem is that each side of a rhombus has the same length. And since the perimeter is 52 meters, we can let the side length x be x to get that perimeter, which is equal to 4x, since x plus x plus x plus x is equal to the perimeter. But the perimeter is also equal to 52. So solving, we get that x is equal to 13. Now we know the side length of the rhombus. And we can approach this problem in some ways, but by far the simplest is just notice that the area of a rhombus is 1/2 the product of the diagonals. So if we let this be the black segment, DB be the black segment, and AC be a blue segment, then the total area is equal to black times blue. Or you can just say DB, black times blue divided by 2. Or you can say BD times AC over 2. So they already give us the length of AC, which is 24, which means that since the rhombus's diagonals intersect at the midpoint, we know that if we denote the intersection as E, that EC is equal to 12. And we also know that since this is a rhombus, the diagonals are perpendicular. And now this triangle is starting to look very familiar. So let me just redraw it here. So we have a triangle, right? This is the blue side. And then we have B, C, and E. Alright, so we know that this blue side has length 12 and BC has length 13. Thus, since we actually recognize this as a Pythagorean triple, that being the 5, 12, 13 Pythagorean triple, since 5 squared plus 12 squared is equal to 13 squared. So, we know that BE is 5. But if BE is 5, that means that the total length of BD is equal to 2 times BE equals 2 times 5, which equals 10. And now we're ready to find out the area. The area is just BD. So area is just BD, which is 10, times AC. AC, if we remember, is 24. And then we divide by 2. And when you calculate this, this yields 120. When you look back at the answer choices, you see that this is choice D, and we are ready to move on. Now, here's our final problem with the set. A tortoise challenges a hare to the race. The hare eagerly agrees and quickly runs ahead, so we know that the hare was ahead of the tortoise, leaving the slow-moving tortoise behind. Confident that he will win, the hare stops to take a nap, so we have to note that he stops. Meanwhile, the tortoise walks at a slow, steady pace, so slow, steady pace, steady is the important keyword, for the entire race. That's also important. The hare awakes and runs to the finish line, so we know he awakes and runs, which means he stops napping and starts moving again, only to find the tortoise already there. So, if the tortoise is already there, that means the tortoise beat the hare. So, which of the following graphs matches the description of the race, showing the distance t traveled by the two animals over time t from start to finish? So, the first key fact that we have here is that the hare runs ahead. Since the hare runs ahead, we look at all the solutions, and we see that the hare has to go in front of the tortoise. Now, looking at all of these, we actually see that all of them match this description so far, since they all have one line that has a steeper slope than the other. But confident that he'll win, the hare stops to take a nap. So we know that the hare stops to take a nap, right? The thing is, the hare is the line that was moving faster. So, for example, in choice A, the line that was moving faster is the one that's leveled off. Same with B. However, in C, instead of leveling off, it actually went down. But that's not what we want. We want it to go straight. So thus, choice C is eliminated. Choice D, for the same reason A and B, looks fine. Choice E, however, the hare moves ahead in his nap, which is obviously not what's happened. So E is out. Next, we see that meanwhile, the tortoise walks at a slow, steady pace for the entire race. So in A and B, both A and B, there's a slower, steady line. And this line is the tortoise. And as you can see, its velocity never changes, which it makes sense because it walks at a steady pace. However, in D, there's one point where the velocity of the turtle changes, and that is not what we want. So again, D is out now. So finally, we've narrowed it down to A and B. Now, we notice that the only difference between A and B is that in one of them, the faster creature makes it to the end first, and the faster creature in this case is the hare, and in B, the slower creature makes it to the end. The slower creature makes it to the end first. Not this. The slower creature, so here. In this case, the slower creature is the tortoise. Now, if we look at the problem, it says that the tortoise is already there when the hare reaches the finish. So, that means that the tortoise won. And since the tortoise is a smaller creature, we can see that choice B is the correct answer. And we are done with this problem set. Thank you so much for watching. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please comment down below or email me at steamaspirations@gmail.com. Once again, this is Vishnu Manjipudi, signing off. Bye, everyone!